So this is going to be graphing a quadratic equation, kind of a cookbook approach. I'm just going to give you a little recipe to follow, per se. And the first step we're going to do with this is, with this equation, is it's in standard form, which y equals ax squared plus bx plus c, which is kind of nice, because this tells us some kind of nifty things. First off, we know a is negative 2, b is 4, and c is equal to positive 3. Alright, what's kind of nice about this is we can look at a immediately and tell what the graph's going to do. Because it's negative, I know my graph is going to open down. It's sad when it's negative. Happy when it's positive. So we know it's opening down. The 2 means it's going to be slightly narrow. So it might look maybe something like that. Somewhat narrow. If it was, say, a was 0.5 or 0.3, it'd be really wide, or wider anyway. So generally we got the feeling for the graph. B, we'll talk about B in a minute. C, only when it's in this form, C is your y-intercept. So I know my y-intercept is up 3 on the y-axis. 1, 2, 3. Right there is my y-intercept. Here's y-axis, here's x-axis. Or in our case, I guess I have it as a function f of x. Okay, so we've got our y-intercept. We've already got a point. Good deal. 0, 3 is the y-intercept. Next thing I find is the x-intercepts, and you find that by the quadratic equation. But there's other ways. You might be able to factor it. Who knows? So x equals negative b plus or minus the square root of b squared minus 4ac. You know, if you don't know what the quadratic formula is, you might go look at a video that I produced on the quadratic formula. I think I have several. And just so you can refresh how to do that. If you don't remember, good to go back and look. So I'm going to keep going with this. We got negative 4 plus or minus the square root of 16, and 2 negatives here become plus a positive. So we got 16 plus 24 all over negative 4. Okay, and just kind of keep on simplifying. Negative 4 plus or minus the square root. 16 and 24, that's a 0. Looks like square root of 40 over negative 4. And we can keep on going. X equals negative 4 plus or minus. 40 breaks down into 4 and 10. 2 and 2. You'd have 2 root 10 all over negative 4. And you could finally finish simplifying that to x equals negative 4. Oh, excuse me, take a 2 out of everything, and you'd have, or take a 4 out, and you'd have negative 2 plus or minus the square root of 10 all over negative 2. Alright, so now you can get your calculator out and approximate that, so we can go ahead and plug it in. And so I'd have negative 2 plus the square root of 10, and then divide that by negative 2. I'm just getting out a calculator here. And I know one x-intercept is approximately equal to negative 0.58, because it's irrational, comma 0. And then the other one, you do the minus side of that, and it would be negative 2 minus the square root of 10, and then divided by negative 2. And the other one is going to be a positive 2.58, comma 0. And again, I'm just approximating it. So we can go ahead and graph those 2 points. So negative 0.58 would be about here. 2.58 to 1, 2.58, about there. It doesn't have to be perfect. So you can see our graph starting to form. The next thing you need to find, the last thing, is probably the most important part, is the axis of symmetry and the vertex. So we'll go ahead and find the axis of symmetry. It's the formula x equals negative b. Now we're going to use that b term over 2a. So negative b over 2a. So we're going to take that negative b over 2a. I'll go up there. B was 4 and a is negative 2. There it is. So my axis symmetry is minus 4 over 2 times negative 2. So x equals negative 4 over negative 4. So my axis of symmetry is x equals positive 1. Now this shouldn't be right between our two x-intercepts. And if you look at that, positive 1, you bet. There it is. There's my axis of symmetry. And then you can mirror that point. Any point to the left can be mirrored to the right. So I'm mirrored my y-intercept point right there. And the last thing you need to find is your vertex. Okay, the highest point in this case. So my vertex in this case, use your axis of symmetry. It's going to follow along the axis of symmetry. It's going to be 1 comma something. So take that 1 and plug it into our original function. So our original function, so we're going to find f at 1 equals negative 2 times 1 squared plus 4 times 1 plus 3. And so you solve all this out. You have negative 2 plus 4 plus 3. So that becomes 5. And so 1 comma 5 is our vertex. So we'll graph that and we're done. So you go right 1 from the origin up 5. 1, 2, 3, 4, 5. There's your vertex. And there is our graph of our parabola that opens very steeply down, very narrow. And for the most part, we're done. Now, you can check that in GeoGebra. So I'll pull up GeoGebra quick. And shouldn't take me more than a second. There we go. There we go. First one. Takes me just a minute to load it. I should have had it loaded already. I'm sorry. We're going to take a little bit of time while it loads. And as long as I keep it under 10 minutes, we're going to be good. So, speeding along. But, I mean, granted, I want you to be able to do these by hand. But all the technology out there, they can all do this for you. But you still got to be able to do it. So the first step, I'll pull this in. You can just type it in just like a function, just like the original. Equals negative 2x squared. Use a caret key for the exponent plus 4x plus 3. Hit enter. And voila. It graphs it. There it is. If you wanted to find your vertex and some of these other points, there's 1, 5. X-intercepts. I'll intersect the x-axis and there they are, negative 0.58 and 2.58, and I'll intersect the y-axis now. 0, 3 is your y-intercept. So we've verified that everything I did was correct, and that's how you can graph these. So good luck. Try them on your own. If you need help, find somebody that can help you, or me if I'm around. See you later. Thanks for listening. Goodbye.